Okay, let's give you guys an integration problem. So it's similar to the previous video, but this time we've got y equals the square root of x, which is this red line here, and y equals the cube root of x, which is this blue line here. Find the area in between the two. So find this area here. So press pause and have a go. Okay, so to do this, the area equals the integral from 0 to the intersection of the two. We need to figure it out. So we need to figure out from 0 to the intersection of the two is going to be something dx. But we need to find the intersection of the two. So remember, square root of x is really x to the power of a half. Cube root is x to the power of a third. So to find the intersection of the two, ask yourself, when will this be the same as this? So when will square root of x be the same as the cube root of x? So to solve this, let's cube both sides. So when you cube this, it will be 3 over 2 equals x. So when you cube this, it would be like this: cube this side, cube this side, and then this times this will give you 1, and then this times this will then give you this. So now from here, let's imagine this as being x to the power of 3 to the power of a half, and this is x to the power of 1. Let's imagine this as being this. So now you can see you've got a square root. So now square both sides. So that will then give you this. Square this side, and then square this side. It would be to the power of 3. So now, I hope. Well, let's divide both sides by x squared. So that will then give you this. Well, this is a very crude way of doing it, but you can do it like this. Divide both sides by x squared. Remember, just bear in mind that when you divide by x squared or x to the power of 3, just know that something weird happens. You're not allowed to divide by 0, but because we know we are trying to locate this point, you can't really divide. We know we're not going to divide by 0 because we are somewhere to the right of 0. So when you divide by x or x squared or x to the power of 3, just have at the back of your mind that it cannot be 0. But we know here this will never be 0, so we know it's going to be a legitimate move. So this is okay. Well, the point is that this point here is actually 1. So we are actually integrating from 0 to 1. Okay, so let's start again here. We are trying to find this area here. So the area equals the integral from 0 to 1, because we've just worked it out. And then it would be hang on, so we're moving along like this. We've got to get the, let's just say currently x is here. We need to get the blue line, take away the red line. So the area equals the integral from 0 to 1. So we need to get the blue line, which is x to the power of a third, take away the red line, which is the square root of x, which is x to the power of a half. So that's the whole thing. That will then give you the height in between the two. So if you're moving along, it will give you the height in between. You're summing up all the heights in between the two. So it would be this. So the area is actually given by this. So this thing here will then give you the height in between the two. The height in between the two. And you're summing up all the heights in between the two. From 0 to 1. So the area is given by this. The area is given by this. So now it's just a matter of integrating this. When you integrate this, it will give you this, and I'm expecting you to be able to integrate this. We've done this many times. Integrate this, it will give you this from 0 to 1. So now put 1 into here, and when you put 1 into there, it will be 3 over 4, 1 to the power of 4 over 3. But 4 over 3, you can visualize it as this. You can visualize it as to the power of 4 to the power of a third. You can visualize it like this. So hang on. So it's like this, and 1 to the power of 4 is just 1. 3 over 4, and then the cube root of 1. You got to think of a number when you times by itself 3 times, it gives you 1. It turns out to be 1. 1 times 1 times 1. Well, the cube root of 1 is 1. So it's just going to leave you with this. And when you put 1 into here, you can use the same argument. It will give you this. And when you put 0 into here, it will be 0. When you put 0 into here, it would be 0. So it's really you doing this. Take away 0, take away 0. But then it's going to disappear, leaving you with this. So simplify this. It will give you 1 over 12. So that's your final answer. But in the previous video, I gave you this. In the previous video, I asked you to work out the area here, and the area turns out to be 1 over 12. And then in this video, I gave you this, and the area also turns out to be 1 over 12. So these two areas are the same. And the reason for that is when you look at y equals x squared, the square root of x. Hang on, let me think. Sorry. The square root of x is really the inverse of x squared. So when you have x squared, the inverse is always a reflection along the diagonal. So when you reflect y equals x squared, it will give you this. It will give you the square root. And when you this is the inverse of the cube root. So when you inverse, you're going to reflect it along the y equals x. So it's going to be a reflection. So it's going to look something like this. And then in between the two, well, the point is that when you reflect it along the y equals x line, when you reflect it, it will preserve the area. The area doesn't get stretched or squashed. A reflection will always preserve the area. That's why this is 1 over 12. And then in this video, it's also 1 over 12. There's a connection in between the two. Okay.